Good afternoon, ladies and gentlemen. Welcome back after lunch. Uh, it is a difficult session to keep awake, and the subject is also fairly technical, but I'm sure our speakers will be able to uh, bring a lot of excitement into this session. May I please request the panelists to come on the stage? We are the chairperson for the session on SpaceCom for military space-based communications for informatized battlefield is Rear Admiral K.M. Ramakrishnan, VSM. He's ACNS CS NNCO, Indian Navy. So, may I please request you? May I request Colonel Amit Oberoi to come on the stage? Air Commodore Kane sir is just coordinating on his presentation. He'll join us. May I request Colonel Vivek to come on the stage? May I request Commodore MP Rajesh Nair, Commodore NSO Indian Navy, to please come on the stage, sir. May I please request Rear Admiral K.M. Ramakrishnan to make his opening comments as the chair.
Good afternoon, ladies and gentlemen. At the outset, I must thank the organizers, the Indian Space Association and Geospatial World for putting together this conference on a subject of contemporary relevance, not just for the defense forces, but also for many other players in the country, spanning right across the various users to the government agencies providing services, space-based services, and the private industry. It is indeed a pleasure and a privilege for me to chair this session. I see quite a few of my illustrious seniors here in this audience. Thank you so much for attending this. Space, along with cyber, have emerged as critical dimensions that would have an effect much beyond the armed forces in case of a conflict. Space-based communication in particular has seen rapid development in technology, reduction in costs, and increasing participation by private industry that is helping nations innovate and strive for battlefield dominance. The geographical operating spread of our defense forces, especially in the maritime domain, has made space-based communication and surveillance the backbone of our networked operations. Today, medium and low Earth SATCOM constellations, technological advancements to exploit higher frequency bands such as the Q and V bands, and faster processing techniques is enabling lower latencies and improved bandwidth utilization. In addition to providing connectivity to the remotest parts of the globe, satellite technology is also heralding IoT connectivity, operations of autonomous vehicles, remotely piloted aircraft, availability of data relay between satellites through TDRS, that is tracking and data relay satellites, along with geographically dispersed ground stations, is aiding our OODA loop and reducing the sensor to shooter time. Further, processing of the large amount of data which is downloaded, including historical data, requires advanced data fusion and processing algorithms using BDA and machine learning for timely, actionable intelligence. Towards this, I would take this opportunity to urge the industry to develop technologies that would reduce time latencies and aid decision making, while also ensuring the requisite military-grade security in our space-based communications. I also believe that Indian private players can bring in the much-needed innovation for developing space-based applications and services, and increasingly nations are going in for a combination of commercial solutions and captive assets, and we also need to explore this. We also look forward to the Indian industries competing in satellite-based services and ground-based segments, in addition to being patent holders and suppliers of components and subsystems. The recent initiatives in space policy are significant steps towards creating a vibrant space ecosystem with participation from Indian private industries. The armed forces, I'm sure, are looking forward to working jointly with the industry to develop space-based surveillance, communication, and PNT, which is positioning, navigation, and timing capabilities. In order to discuss more on satellite communications, we have in this session speakers from the defense services. The topics span from military aspirations from space, emerging trends, space-based tactical battlefield communications, and electronic warfare in space. My only request to the speakers is to adhere to the allotted time so that we have more time for discussions at the end. Without much further ado, I would like to now invite the next speaker. I guess it's Colonel Oberoi.
Yes.
Could I request you to come to the stage, please?
So, good afternoon, ladies and gentlemen. I am Colonel Amit Oberoi. I am the Director, DSA, handling the Indian Army satellite communications. As you're already aware that it came up in the papers that Indian Army is about to have its own satellite, GSAT-7B, shortly after the MOU is signed with ISRO. What we are looking for in the future is to support the satellite. We are looking for some Ka-band terminals as well as some UHF handheld SDR terminals. So we'll be floating a EOI for that to get in touch with the industry, what all support can be garnered. And thereafter, we will go in for a project for these two terminals specifically. So much so, I've been given the topic emerging trends in satellite communications. So I'll restrict myself to satellite communications, and I will run you over through an academic research which I have been reading and getting through. And after this, I'll just give you a small overview of what is it that we are expecting in the future. Fine? So a little bit of a technological perspective for all of us to understand is that while the requirement drives the technology has a symbiotic relationship with the requirement. And the technology at times generates the requirement. You'd suddenly realize that there is a technology which exists, which you can exploit, and yes, you can utilize that. So as far as niche domains are concerned, and specifically space, right, we cannot go linear as an industry and wait for a requirement to come up, then come up with a solution, and then say, okay, we will launch these assets in space, and this is the way, okay, we will realize them. But it's a tough call because it involves investment, and therefore I can only urge the industry that today, 2022, the era is that you have to adopt a fail-forward approach, and you have to get into the niche technologies that are emerging now. So when we come to communication can be, interpersonal, intrapersonal, etc. We always have these basic aspects. You're a sender, you're a receiver, and you have some noise, right? And it's very similar to same thing happens in technology. So all forms of communications are against noise, right? You have to overcome the effects of noise in some form or the other. Fine, right? And another aspect is that communication is information, right? You cannot delineate communication from information. And when you look at communication, it subsumes ISR, intelligence, surveillance, and reconnaissance, as well as PNT, positional navigation and timing. It subsumes both of them. They can't exist without communication. And communication is information, but all data is not information, as has been rightly brought out by the previous speakers in the earlier sessions. Only meaningful data is communication. So something for us to just be cognizant of. And with that, I will come on to what are the trends in communication. I will just a small disclaimer. Everything is unclassified and is pure research, authenticated research, right? So what are the latest trends in SATCOM? First, I'll list them out. Then I'll show you some pictures and I'll end because I have only 5 minutes as given by my friend, Mr. Kushwa. One is today, the gap between the terrestrial and the non-terrestrial networks is closing in. There is deep convergence between them. With 5G in the offing, you require mission-critical, pervasive, ubiquitous communication at all the places. And by the way, today, the ITU study says that only 20% of the landmass and 5% of the ocean are covered by terrestrial communication. And therefore, the need for satellite-based communication, which is only going to increase, right? Now, if you need to increase that, it is going to rise into an era of mega constellations. like what was brought out by Pixelair, they are having their own constellation of just 6 satellites. I'll show you some data wherein the constellation planned have satellites as many as 35,000. Then is the era of non-GSO, non-geostationary orbits, because it is firstly less costly, it's got low latency, and it is pervasive with a constellation in place. And when you look at this, what comes to your mind is that the entire satellite communication architecture will be multi-layered. You will have a few gateway satellites and you will have inter-satellite links between the satellites. The era of high throughput satellites has been there since last about half a decade, in fact more. But it is the next gen high throughput satellites which will have spot beams and frequency use, therefore making the satellites very, very efficient. You will have RF to optical conversions. So the inter-satellite links will be on both optical as well as RF. And as has been spoken before, what is already taking place is that there is going to be satellite-based IoT. When I say satellite-based IoT, I mean even the devices will be able to transmit back at even low bit rate or narrowband channels back through the satellite medium to the central control as sensors, right? Okay. Then many functions of satellites will be based on artificial intelligence and machine learning. And we are already having some adaptive modulation schemes in place which will take care of channel conditions like rain fade, etc. And therefore, the layered architecture will be well poised in the future for deep space exploration as well as interplanetary satellite links, right? There is a challenge for providing communication for fast moving platforms, and therefore you have to look at provisioning communication for platforms which can change their course at any point of time. And for that, there are challenges wherein you need to carry out the channel estimation, which is time varying. And you have to look at high mobility, multiple access, some of these schemes which are still being researched, but are going to be realized very soon. Satellite architectures will be reconfigurable. In fact, some of them already are. Like the person whom I was speaking with, his satellite, which is the LN satellite, has got a SDR in place. You will have communication between two different nodes taking place through the satellite network, and the satellite network by itself is a software-defined network which can modulate the traffic based on the requirements. And therefore, when you see that there will be a congested space, then the spectrum will be contested, and therefore people have started looking at cognitive radios which will share the spectrum and intelligently and have primary and secondary users. At times satellites will be primary users, at times the terrestrial networks will be secondary users. Then the concept of reflecting intelligent surfaces has been talked about. They are passive surfaces like the HAPS, which was shown, high altitude pseudo satellites, wherein the surface will reflect the high frequency beams which otherwise get absorbed, and also for supporting the ground or the terrestrial user equipment, right? But this is a problem which is still being researched. It's a non-convex problem which is yet to be solved. Then people have already started talking about optimizing the way you throw data to the respective users based on the content which needs to be shown. So a particular area requires high bandwidth video content. The entire cloud, satellite-based cloud, will be able to support that. Of course, the machine-to-machine and the IoT, right, will push for greater demand. Everybody will look forward to that particular resource at the same point of time, and therefore the multiple access schemes such as non-orthogonal multiple access, right, and dynamic beamforming will be in place, right? And the era of small satellites, like was brought out, or the 10U satellite or the 1U satellite, the CubeSats, which are just a fraction of the cost, are the ones which are used for experimentation, also for channel estimation in the Sir brought out in the V band as well as the W band, which are being explored. They are bands at very high frequencies, right? From 50 megahertz to 150 gigahertz to 110 gigahertz, which will also give very high throughputs, but they require some sort of research and ratification, which can be achieved through the CubeSats. So some figures, right? You have convergence of 5G and SATCOM through a multi-layered architecture. So you have, you have fixed landline, airborne, maritime, cellular broadband. You have backhaul, which is based on satellite backhauls. Another figure, which shows you a layered architecture wherein the geo platforms give you the backhauls for the MEO as well as the LEO platforms. The same concept here. And this is not far from being realized. I'll just show you some data very soon. Then you have the next gen HTS, or the high throughput satellite systems, right? Wherein with the same amount of frequency, you will be able to increase the throughput. So they're talking about a full throughput given by a satellite up to terabytes. Then some of the systems are using MIMO, but they are looking at MIMO being used by satellites in these forms, wherein 2 satellites, 2 stations, 1 satellite, 2 stations, so 1 by 2, 2 by 2, but using satellites. Of course, I talked about the adaptive coding and modulation. And this is the data taken from 2020 journal of IEEE Access. This is what has been approved by the ITU. Fine. So if you see something interesting over here, you'll find, of course, Starlink 12,000. We all know that. It'll increase to 30,000 later once they get the permissions. You go down further, you find Facebook. They're trying to get listed, right? It's quite interesting. Let's see the next one. You have Astrom Technologies from India, 198. But I believe I came to know today that they have 2 years to launch and possibly they are going to give up. After 2 years, they have to take the permission once again. Pixel, which said that their 6 satellite constellation is in air, is not listed as an Indian company. So total number, this is actual ratified data, is 35,015 as of 2020. It would have increased 2022. It's not yet been published. So let's have a look at the spectrum utilization by satellite over the years. So as we progress ahead, we are going to look at utilization of the V band, the W and the W band, the Q, V and W bands as well. And we are going to look at massive or mega constellations, including very low Earth orbit satellites. So the inter-satellite links are crucial for the LEO satellite constellations to work effectively. There's a whole lot of research going on there, and if you see the whole thing, you find that the complexity involved is also huge. It requires niche research. It's already in place. Starlink already has these inter-satellite links in place. The satellite-based IoT, just imagine that you can have all the remote areas, all the sensors along the landline, along the coastline, etc., covered by the satellite-based IoT. But this is pure satellite-based IoT which I'm talking about. And the reflecting intelligent surfaces. These intelligent surfaces manufactured with certain material get dynamically aligned to the frequency being transmitted and support the user equipment which is on ground, which otherwise will have deep fading because of the high frequencies being used. And lastly, these are the various areas in satellite communication. For example, beam hopping, energy managing, interference managing, traffic forecasting, etc., which can be utilized by using artificial intelligence in satellite communication. So that's all the time which I had. I could have gone on for 2 hours, dwelling each one of them. These are my references. If anybody is interested more, then he can go through my paper, which I'll be, putting it out in the open shortly. Thank you. Thank you so much.
Thank you, Colonel Oberoi. May I please request Air Commodore M.R. Kane, Air Commodore Ops Com, Air Headquarters to make his presentation.
Jai Hind, everyone. That's the problem with this topic, the first speaker, he's covered almost everything. So I really shudder what the speakers after me are going to do. But anyway, I'll cover it from the Air Force perspective as to what we are looking at from satellite communication. As far as I see it, for Air Force, though it's a strategic asset, but primarily we need to deploy it for tactical requirements. Prime usage is its rapid deployment and the rapid relocation that can be carried out with a satellite terminal. That's a very big advantage that we accrue. Secondly, the modern satellites, because we are data hungry as far as the Air Force goes, because there's so much of data which is being generated that finally we require an AI and an MI to read into the data and gel some information and finally transform it into knowledge. So probably in the days to come, satellites with higher bandwidths will be able to utilize them if, say, a big amount of data is required to be transferred from a remote location. It's ideal for an out-of-area contingency. We actually ended up using it during HADR for Op Maitri, where we deployed one of our satellite terminals in Nepal. And right from the word go, when we started, using our service, or rather providing our services to Nepal, communication was available. Communication was available with my mainland. So that's excellent. So that's something, that one can use, make good use of satellite. And of course, mostly in our cases, we end up using it for air defense operations. Because as I said, like quite a few of our assets during actual operations, they are going to be mobile, they're going to be deployed out of base. And once they're deployed out of base, the best form of communication which is available is going to be satellite. So that's the reason where satellite comes into. What are the opportunities which are available to us? LEO constellation. Now, primarily it is being exploited in the civil world for providing internet to far-flung areas. I mean, that's how it started. But now, of course, they have been providing internet and large bandwidths even for the urban population. But primarily, it was required or meant to be for rural areas so that the person in the corner he can be provided services. Now, it's deployed in a constellation, especially say if we are talking about Starlink. Elon Musk, he's already deployed 3,000 satellites in this LEO constellation, and he's applied for a license for 40,000 more satellites. So you can imagine the kind of satellite network that we are going to have orbiting at around 500 kilometers or so. The expected downlinks are going to be somewhere range between say 50 to 500 Mbps. That's what he's targeting. Right now, as I understand, I think he's been able to achieve there's some competition which was held where he won, SpaceX won, and the download speed was something around 150 or so. So that's kind of a downlink speed that he's able to achieve. And of course, the biggest advantage of this is low latency. Unlike a geostationary satellite where it has to travel a distance of 35 into 270,000 kilometers. In this, it's just talking about traveling a distance of 1,000 kilometers. So the latency comes down to just 40 milliseconds. So it's as good as a terrestrial, network latency. So voice and video, that's where we gain when we have this kind of a latency. It provides global coverage. So, we were lucky when I said that we went for Op Maitri because our INSAT satellite, it had a footprint over Nepal. Though, when we deployed that vehicle, we had to carry out a study whether, the beam is covering Nepal or not. And thankfully, the GSAT beam was covering Nepal, and that's how we could deploy it. But in case we have a LEO constellation available, it can be straight away, bandwidth is hired and you are good to go. Jam resistivity. That's one of our major concerns. During actual operations, we think that the first thing that the enemy is going to do is going to jam your satellite communication. So a jam resistivity is the foremost requirement for a satellite kind of a satellite-based network if we are ever, when we use it. Of course, there is complexity and cost involved in it, but right now, the satellites which are being designed in such a manner that when the life is over, they are able to deorbit themselves, enter the Earth's atmosphere, and just disintegrate. So that space debris is reduced and kept to a minimum. High throughput satellites, as the previous speaker has spoken a lot about it. I would just like to mention here that, again, Viasat, it has been able to achieve a capacity of 140 Gbps. So, that's a huge capacity that we are talking about. How it's able to achieve it? It uses targeted spot beams so that energy management is better, and that's how he's able to achieve higher throughputs. Frequency reuse. So the same frequency is used in, multiple beams. And because of the beam width, jamming becomes extremely difficult. So that's one major advantage that we have here with high throughput satellites. And GSAT 19 and GSAT 29, which has been launched by ISRO. So they are carrying out experiments on these high throughput satellites as far as India goes. High altitude long range UAVs. These are basically UAVs which are flying in the stratosphere, and the US, they have deployed Zephyr. What happens is when you are deploying an asset which is required to provide you communication, the time on station, that would make a difference, especially when you are looking at this kind of a tactical asset. But Zephyr is known to have an on-station time of 25 days. So that's a recorded time on station, and that's a fantastic figure that we are talking about here. So it is also known as a high-altitude pseudo-satellite. Then we have high-altitude platform stations. These again are highly tactical in nature, just like the previous one that I talked about. And the characteristics are similar when we talk about the satellites. They can be deployed, very easily, and just at the time of requirement, just in the nick of requirement. If I have to carry out an operation, I need to deploy one, it's available to me. But I personally think that this is the biggest development which has taken place in satellite communication, is the launch of quantum satellites. That's kind of shaken the world, and China has taken a massive lead in this. With this deployment under Mission Quest, it's led by Jian Wei Pan. He's the scientist of China Science and Technology University. He's the one he deployed the satellite in 2016. And along with Austria, they have been able to establish a VC using quantum communication. So that's really fantastic. And this has given rise to quantum encryption and quantum key distribution. Key distribution is a big issue, but then with this, the qualities of quantum mechanics, they make it possible for carrying out a secure key distribution required for encryption. And experimentally, they have been able to distribute keys over a distance of 4,200 kilometers in China. So that's something, worth taking note of, because here we are struggling with, transmitting keys without physical movement of a Jawan or an air warrior or a sailor, because he has to move all the way from point A to point B right up to Delhi. What that point B happens to be Delhi. Wherever he is, he has to move up to Delhi and, get the keys. So now if we have this kind of a system available with us, you can imagine, the way we can do our encryption business. India is not far behind. ISRO has also been conducting experiments, although the distances which it has been able to achieve is not much. When we are talking about a VC between China and Austria, or say quantum key distribution over 4,200 kilometers, the distances which they have been able to achieve in terms of, communication and quantum key distribution, the distances have been small. But yes, we have made a start, and I'm sure we should be going places. But what are the challenges that we are facing in respect of satellite communication? I will not refer to The basic challenge that we are finding out is the vulnerability of the satellite network. This network, actually, I think amongst all the networks which are available, this would be the easiest to hack for our adversary. So that's the biggest challenge that we are facing here. And how he does it? Because the devices which are utilized, which are used to establishing the link, they have hard-coded IDs. And those hard-coded IDs, they are the Achilles heel for us. So what is the solution? Solution is make in India, develop our own hardware, so that develop our own security protocols, so that security can be taken care of. The second thing is it is prone to jamming, and we have used our own systems where one can actually jam on the satellite network. And with the kind of satellites we have right now, is if you end up jamming that satellite, you are jamming the entire network pan-India. That's the main, that's the bigger problem. Whereas where you have spot beams and, pencil beams available, jamming a network pan-India will be a much difficult proposal. So again, probably you may not be able to stop him from, sending up jamming signals. But then if you are able to find out where that guy is, yes, that could be one of the solution. And of course, making anti-jam, jam-resistant satellites. The equipment per se itself on board. With so much of, equipment floating around the space, there is a requirement of space situational awareness. So we ought to know, like, where the adversary satellite is, where our satellite is, what it's doing, whether it's trying to jam us, what are the frequencies at which it is transmitting, and host of other things. What are the parameters, of the communication which is being carried out. So, and of course, finally, with all the situational awareness, we should be in a position to profile him. Finally, the future technologies that we are looking for, IF, it's high throughput satellites. I think that's the buzzword. Whatever we say, data. So more the data, better it is for everyone. Onboard anti-jamming facilities, and of course ASAT, but I don't know how, whether we actually end up using it or not, but as a technology and as a weapon, it needs to be there with us. And finally, a software-defined SATCOM network, where you have a single hop efficiency available, and you are able to fit all kinds of topology into a single satellite, and a single router is able to carry out all the functions that are expected out of the network. So software defined network, that's, the next step that we would like to go to. So that's all from my side. Thank you very much. I think I have adhered more or less to the time limit. Thank you.
Thank you very much, sir. May I please request Lieutenant Colonel Vivek Gopal, Instructor MCEME, to make his presentation.
Very good afternoon, ladies and gentlemen. And I must thank the Geointelligence 2022 team for giving me this opportunity to speak in a beautiful forum like this. It's always good to be here. And after a gap of about 2 years, it almost feels even more reinvigorated. Well, most of my speakers earlier, they've spoken about satellite communication as such, what communication's got to do, how it's going to be helping them. I'll just give it a different flavor. I'll talk about what would you do in case you don't have communication. That is, I'm entering into the realm of electronic warfare, where I assume and I foresee that communications are actually not going to be taking place the way we intend them to be. We might have lots of plans, we might have a lot of redundancies which have been catered to, but when we talk of electronic warfare, this is exactly what we don't want should happen. So my talk over the next 10 to 15 minutes is going to be on space-based electronic warfare. And instead of mentioning the technicalities and the systems which are actually involved, will just be a brief overview. My purpose here today would be to probably give a few pointers which, when taken home, will most probably help us in shaping a policy, if at all we need, for developing electronic warfare, and that too now not ground-based systems or aerial systems, but space-based systems. So space-based EW is what my talk is going to be. Of course, it's going to have very little technicality involved to it. Coming on to the first slide, this is just a pictorial representation of trying to tell the audience as to, the kind of money that's actually getting invested. We are having sensors in air, water, land, sea. At the same time, we are trying to use these, funnel this as an effect, and try to get the effect again. And we are again investing dollars to ensure that this information is not happening. So it's a very funny kind of a situation. You're investing billions of dollars to have assets in place to give you ISR. At the same time, you're also investing billions of dollars to ensure that these assets don't do their intended job. So this is the kind of, cat and mouse game that is always on with electronic warfare. So what is the present conflict paradigm which is actually wanting space-based electronic warfare to actually come up? This basic question would actually come to a lot of minds. All right, we've got electronic warfare over land, air, sea, maritime, whatever we might call it. But then what's the need of space-based warfare? So the reasons are very, very simple. Firstly, the spatial dimension is enlarged. There is no geographical boundary which actually constricts you to wage a kind of warfare that you're looking at. So all those lines that we've drawn on maps or wherever we feel comfortable, they cease to exist. The moment we have electronic warfare, we are looking at blurring of boundaries. At the same time, we are looking at the mutation of the belligerent's identity. What do we mean by that? The technology as such has got democratized. Non-state actors have access to technology. So one might not see somebody wearing fatigues or a uniform actually trying to ponder along with electronic warfare. It could be a person who's working in his basement trying to, spoof GPS signals, which are going to be a part of electronic warfare. So the very way the conflicts are going to be seen in the future have forced us to rely on means by which electronic warfare can actually be now conducted from space. So this was a slide was basically just trying to tell you what the present conflict paradigm is going to look like. Having said that, what are the threat vectors that come up? We have the electromagnetic spectrum, which I have called somewhere in the last bullet as a maneuver space. The ones who are wearing the OGs, we generally like to talk of maneuver warfare. And when we talk of maneuver warfare, we generally associate it with AFVs or armored vehicles. But it's high time now that we started using space as that kind of an element which invites us to do that kind of maneuver warfare even in space. So that is why maneuver warfare, the spectrum is to be treated as a space for maneuver, and we need to ensure that our EA, EP and ES policies are in place so that we can make maximum benefit out of it. At the same time, this is a brief overview, and the source has been mentioned. It was there. It was published as one of my papers. And although when I had studied this subject, I had taken it from the CSIS as an authenticated source. So when we look at the capabilities of China, you see the entire domain of EW has come under the PLA SSF. Chinese, of course, we need to, I'll not say really worry about, but we need to take note of very substantial capability that they've developed. The part of quantum was covered before me, by the speaker before me. RPOs are another activity which the Chinese have taken a leap forward. The remote proximity maneuvers or the rendezvous proximity orbital operations are such that they can carry out repairs of satellites. They can tailgate a satellite. We've had experiences where there has been a blackout. Our own imagery satellites are moving over an area and suddenly we see that we are not able to detect anything. And the best part about using RPOs or using space EW, which I always maintain, is you've got plausible deniability. You were there, but you were not there. Whatever you were doing, fair enough, nobody can prove it. So that's the reason RPOs is something which we need to take attention of. At the same time, the kind of investment that they've made in space-based EW, I've mentioned the two establishments. One is the CASC 509 Institute and the SWIEEE. They're two leading institutes which are working in the domain of space-based electronic warfare as far as China is concerned. Also, if we look at the graph, which has been shown by dots, you'd see in terms of SSA, that is space situational awareness, and electronic warfare, we have operational capability when we look at China. That's why you see the green dot there. Whether they have been employed in operations or not is obviously something which will never be validated in open source. Moving on to the Russians, again, we see in electronic warfare 4 green dots. That is because courtesy the operations in Syria, Crimea, and now in Ukraine, they have proven capability of electronic warfare in field. So we see the 4 green dots there. Again, look at the kind of Russian systems that have been developed. We've got the Peresvet, we've got the Tirada 2S, we've got the Krasuka 4, which was recently in limelight, courtesy the Ukrainians who caught hold of a system. And also, we've also got the Bylina KV and the MM. They're 2 very potent systems which are being used as part of Space EW. Similarly, moving on to the US, again, we see the green dots there as far as the space-based EW is concerned. And look at the kind of programs that they have. They have the NAVWAR, which happens to be classified, very little data which is available on the open source. They've got the NROL 44 satellite and the AEHF-5, which is a high-frequency satellite which they intend to use for the purposes of electronic warfare. Now, we talk exclusively of China, and why the focus is on China is for obvious reasons, which actually does not really merit any greater detail. But when we look at the various things that they have done, look at the first thing. They have a doctrine or a policy in place. This is the point which I try to drive home about. As I said, this talk is all going to be less technical, and I'm trying to bring home to the point that we need a very effective space EW doctrine or space EW policy in-house. So we look at the Chinese, they have a doctrine, and it very clearly states that they have transitioned from savage power to smart knowledge. Similarly, they also have technology which they are going to leverage. They have the latest example of the Iridium 108 satellite, which was hacked. Similarly, they have cyber situational awareness satellites, and the list goes on. However, in India, the only space event which I participated in, and therefore I know of, is a NASA Space Challenge, which happened to be on Bangalore. And that too is developing space applications. They are not really entering into space electronic warfare per se. Coming on to DRO, topic which probably would need an entire session devoted to itself. The kind of cislunar orbits that the Chinese are exhibiting interest in is something which is very, very noteworthy. The good part about DROs or the distant retrograde orbits compared to the normal orbits is basically putting the satellites on those famous Lagrange points L1, L2, L5 so that you can have lesser reduced launch costs. You can put a satellite in orbit and it can continue to be in that particular place for a time immemorial because it's held by the gravitational forces of the heavy mass and the lighter mass getting balanced out with each other. That's the very concept of how DROs are actually functioning. The cislunar orbit is something which the Chinese are showing great interest in. Similarly, we've out research universities. I was discussing it today with some other panelists here in the forum. And it's actually noteworthy the amount of funding that the Chinese are actually making to ensure that the students actually study abroad. The kind of resource network that they're having, their professors, their PhD scholars, the way they are teaching their own students, they are ensuring that that knowledge management actually takes place. Most of the research is being funded by those foreign universities, and the fruit is actually being taken by the Chinese. And at the same time, we're looking at threat to Starlink. Starlink, which again came up in the news recently because of the help that's being offered. The Chinese have very clearly mentioned that they'll be able to disrupt the entire activities of Starlink with the press of a button. So having said that, space EW, why? That is because space is getting militarized. All right, one might say it's got weaponized, but then there is a very thin line which is actually going to distinguish between what is militarization versus weaponization. That's a separate debate in itself. We want strategic autonomy. And nothing could be better in case we are looking at strategic autonomy than from space. It's, of course, a measure of the CNP or the comprehensive national power. It's also enhancing situational awareness. Space, by virtue of the altitude, is giving you a much larger footprint. Because of the larger footprint, it is giving you augmented capability for ground-based EW systems, as well as increasing the space situational and ground situational awareness. And thereafter, your EMS maneuvers in space can help shape the battlefield or the environment. So having established the purpose of why we need space EW, I just like to show you a small animation. The one on the right, that's courtesy my friend sitting here, Mr. Navneet from Kepler Aerospace. What we are actually trying to show here is, if you see the image on the right, you'd see two distinct orbits. The one in red and the one in yellow, if that's very, very clearly visible. What we are trying to bring out here is how a constellation of a satellite is actually going to look like. See, when you're talking of electronic warfare is going to detect a RF signal. That RF signal detection is something which is going to take place courtesy of satellite. But you always would want to visually corroborate that fact. So in case we are looking at a cluster, Just imagine a hypothetical cluster. So that cluster is what is being shown there. A cluster of 4 satellites. The 4 satellites are being used. Why? Because when you want to do direction finding, you want to do triangulation, and the 4th satellite is being used for timekeeping. A speaker here, I think, spoke of the importance of timing signals earlier in PNT. One of the most important things is T. So maintaining that timing on the superbly accurate atomic clocks is going to be done by that 4th satellite. And once those 2 satellites have already made their passes and the direction finding base has been made and you've been able to, triangulate and find a location, you have the 2 EO satellites which are behind it coming on the same track to visually corroborate what has been found. So if we heard the earlier speaker, he showed us tracks of, the radars which were being opened up. But the radar open up was just giving you one kind of a signal. Once the EO satellite goes over that signal, it corroborates that fact that, okay, yes, definitely that kind of a weapon platform exists. Whether it's a radar, whether it was a maritime platform, an airborne platform, that gets done. So this is the kind of development that we want to see as far as space-based EW is concerned. So when you look at the tracks here, now of course the animation is moving. So the red and yellow tracks, as you see the satellites coming down, this is what is actually the EW part. So the EW part comes in, does the direction finding, and the 2 more satellites which are following it are the ones which are the EO sensors. So you are visually corroborating whatever you found using your RF signals. Coming on to this .mlpf framework, this of course I've taken from one of the US doctrines straight out of it, but I found it to be very, very relevant. When we're looking at strategizing for space, when we're looking at a policy framework for space electronic warfare, these are the tenets which I believe can actually help you understand what it's going to be like. So in the .mlpf framework, we've got D standing for doctrine. Yes, definitely it is essential, and I think over the past 7 or 8 minutes, we have harped over the fact as to why we actually need it. Organization. Yes, we need a dedicated organization. I'll go ahead and share a suggested organization with you, which I had published earlier in one of the papers. Probably it's been taken cognizance of. Moving on to training. Training is very, very essential. We generally tend to skip this part. Everybody desires that, we are here and we want to move there. But this journey from here to there, how is that actually going to take place? It's only going to take place when we've got a workforce, when we've got people who are trained. We want electronic warfare specialists. Okay, in World War II, you used to call them ravens. Now we probably like to call ourselves crows. But then we need those trained crows. In case you don't have those trained workforces, then whatever you want to implement in terms of electronic warfare is only going to be a distant dream. Moving on to material, yes, definitely we've got space grade, facilities which are coming up. Now, the nanosatellites which are coming in, they have ensured that you don't really need to rely on very essential space-grade components only, and COTS components can actually be used in nanosatellites. Now, personnel, Space Force, that is, I'm talking about the education which is going to be involved, that I've already spoken. The way the Chinese have actually taken a leap, we need to be investing in such, niche courses, so that EW as a domain doesn't remain the choice of a select few. Everybody is able to understand what EW is all about, understand the nuances involved, and then you can have a certain percentage of people who are exclusively working on that particular domain. But the information is all pervasive. Everybody understands what EW is all about. Leadership. Yes, we have the headquarter IDS with the DSA, and it's also got its other verticals which are supporting it, many other integrated space cell and other organizations which have come up. But are we actually working towards space EW is something which is yet to be answered. Probably I'll leave it open as a question. The facilities which need to come up in terms of recycling, we are looking at nanosatellites. The best part about a nanosatellite is the recycling time. Suppose you have a constellation of, let us say, 24 satellites, probably 4 satellites and 6 planes. Then probably in case you want to recycle a set of 4, then the launch time and the launch cost, which is actually involved for a nanosatellite, is going to be far, far lesser. So you're looking at a much lower capex compared to a proper geostationary satellite that you want to send up in space. Similarly, we need to carry out a SWOT analysis for our own country, because the aim, as I said, of the presentation is to develop a space EW policy framework. So we must understand what our strengths, weaknesses, opportunities, and threats are. We know of our strengths and we also know of our weaknesses, but let's look at the opportunities. The time I had, tried to make this presentation, at that time, Quad was a very burning topic. Can we leverage, associations like the Quad to share technology with us? Because TOT is something which happens to be very, very R&D intensive. And the more time you are wasting, as far as EW is concerned, the entire nature of battle is time sensitive. So in case you want to actually have a lead and you don't want to incur those high costs or end up playing the catch-up game, then probably things like TOTs can actually help us out. Then the defense acquisition procedure that we talk of, yes, we have tweaked it to quite some extent. We also have the fast track procedure which is coming in, but have we made the mark? Again, I leave it as an open-ended question. It's best for us to answer and decide what it is actually going to be. This was the organization which I had thought of earlier, somewhere way back in 2021-22, where we had thought of how the Spectrum Warfare Wing, as I had called it, is actually going to be placed for the country, which is going to subsume the three verticals of Army, Navy, Air Force. So I had at that time suggested that, all right, we have an apex body at the NSCS, which is going to be actually handling all the entire set of activities. We have the various verticals which are coming in, that is the NTRO, the SACFA, the NRSA, DIPAC, DSCC and all. They can contribute. We have typical R&D technical technology clusters, which are based out of, say, Delhi, Bangalore, Hyderabad. And at that time, I had thought that, yes, the National Defense University is actually going to come in. So the part of academia, which I was talking about, I had expected that INDU is something which is actually going to take the lead to have people, experts in the domain of space. And thereafter, it goes on to have the electronic support, protection and attack in the various theaters of land, air and sea. And this is how I was thinking the entire vertical is going to come up. So I'm sure people, the powers to be and the people who can actually make a difference would probably at least notice this, and we make all earnest efforts to at least have an organization in place working on that .mlps structure. The O part, that is the organization part, actually gets catered to there. So what is the fallout which is going to be of an organization like this? We are going to have core capability development. We'll have doctrine and strategies. We'll have a single point of contact where we can develop such space electronic warfare based doctrines. At the national level, we'll have a technology foresight which can take place courtesy this organization. At the strategic level, we'll have technology clusters which are coming in, places which I recommended was identified. That is because of the prominence of the electronic industry there. The use of pseudo-satellite and HAPS is brought down earlier by two of my colleagues here. HAPS is something which we actually need to work out on, and HAPS along with satellites in VLEO and LEO can actually help you make a very beautiful mesh network. A similar work has been done. Study on HAPS was done by me. All the people who feel or interested can connect with me after this talk, and I'd love to share something on HAPS, including how you do the station keeping, what is going to be the temperature difference, how would you actually prevent the drift taking place, so on and so forth, and what will be the target area that you intend to cover in case you've got certain earmarked locations. So HAPS is something that is essentially very, very important. Also, we have self-healing technologies. In fact, today morning, while I was driving down from home, I just happened to go across an article from Mitsubishi Electrical Limited. It's a very beautiful concept, which I thought this would be the right forum for me to share. We all talk in terms of, very large size antennas for electronic warfare. They are just sending a very small parabolic dish, and then they've got something which they call as a resin. That resin goes and, gets plastered onto that aluminum parabolic dish, and that starts to become an antenna. So the base is the only thing that you're actually carrying up in space. You don't have to carry a very, clumsy looking 1.5 meter, 4 meter long antenna with you with constraints of space. Now on a nano satellite, imagine in case I have this parabolic dish and I put this resin on top of it so that I can transform it into an antenna that I want, depending on the frequency that I want. So I can have self-healing antennas in space. I can have antennas coming up in space itself. So this is the kind of technology which is actually coming up. So we need to take note of all this while we're talking of Space EW. The industry participation, but the fact remains that the best part about having industry here, that is amongst the audience, is that I would want the industry to actually work on the bullets that I have highlighted upon. And as I've said, conversation leads to collaboration, and collaboration will lead to innovation. Space EW or EW, for any matter, you need to have an EW mindset. Till the time you don't have an EW mindset, you cannot think of EW. It requires complete thinking out of the box. It requires people to understand the concepts. You might talk of communication all day long. It just takes one man to think how I can get the communication down. You need to have that kind of a mindset when you're looking at EW. And that is where, as I've mentioned, agencies like ISpA, in space, NSIL, they are the ones who are actually going to come, do our hand holding, help us, get these commercial activities in place, form that bridge between what our aspirations are as the uniformed personnel and what we actually desire from the industry, which can help, take Space EW to greater heights. And to conclude, this is a very interesting photograph which I thought just made it on the fly. So you see a crow, as I said, the electronic warfare personnel, they were called ravens earlier. Now they're called crows. So you can have 4 status for crows. You can have status quo. I don't want to enter into EW. I'm happy. The crow is happy. I enter into a paradise situation that is, euphoric. Everything is going to be good. Nobody's going to do anything, akin to Ramraj. It's never going to come up. Conflict. The crow is busy, he's flapping his wings. That's how we should be. That's what the intention of the presentation was. And finally, Semageddon. What is Semageddon? The SEMA stands for Cyber Electromagnetic Activities. So in case we have Armageddon, we have Semageddon taking place, which would show everything and anything in electronics going down. So the point is, we need to rethink, reset ourselves, recalibrate, and finally reinvent so that we can make a difference. Thank you and Jai Hind.
Thank you, Colonel Vivek Gopal. May I now request Commodore MP Rajesh Nair, Commodore NSO, Indian Navy, to give his presentation.
Good afternoon, ladies and gentlemen. I am Commodore MP Rajesh Nair from Directorate of Network and Space Operations of ISpA Median. And at the very outset, I'll promise that I'll just take precisely 5 minutes to cover my part of ship so that we don't extend time. This is the last delivery of the day, so we'll not keep you occupied. So in the next 5 minutes or so, I will be presenting the salient requirements of space communication, the force multiplier for maritime domain awareness. And this is a shade different from what we have heard till now because our requirements are absolutely different. And the audience here needs to understand this because that's how we will be able to take forward the Navy's overall SATCOM requirements in the near future. To give a prelude of before we go to the specifics of SpaceCom, let me give you a small prelude of what the maritime domain looks like. And this is very critical to understand because today Indian Ocean region is a very, very dense area, and it's filled with dense traffic. We have 140,000 ships transiting the IOR every year. And if you see the sheer geographical vastness with the complex situational awareness, which is across the 3 dimensions, and it's a global common, we have extra regional forces operating. So whenever the units are deployed at sea, the only way you can exercise command and control is through communications. And for that, the essential requirements are wide coverage, reliability, redundancy, interoperability, and security. These are the pillar stones of communication, and we exactly know that, and that is how our complete framework of communications are made. And with that as our infrastructure where we operate, where we let our units operate at sea, one of the most important element that gives that capability is SATCOM communication. Because satellite communication is what gives us the capability to undertake network-centric operations at sea. And it allows you to increase engagement cycles, maintain operational tempo. This is because that is where the battles are won, if you are able to maintain the operational tempo. Networking, situational awareness, another cornerstones of NCO are ensured through satellite communication. We ensure mission effectiveness, and today the SATCOM networks are totally integrated with terrestrial networks. So that is where we are looking at how we progress our operations at sea. Therefore, as we move ahead to augment SATCOM infra in the Navy, the requirement hinges on 4 basic principles. The first principle lies on diversity. We need to operate on multiple frequency bands. We need to have indigenous and hired bandwidth for our SATCOM. We need to have dispersed and networked Earth stations because we can't have a single point of failure at any moment of time. We need to augment capacities spreading from GEO constellation. Now we have LEO and MEO constellation available to us. We need to have high capacity transponders and user configurable beams, because today all our transmissions are on a single beam. We are not able to configure the beams to cater for multiple users. Once the user configurable beams are available, we'll have multicast IDs, and hence the NCO efficiency increases much more. And two basic requirements, which while it looks basics, but it is the most important factor which will ensure a better cyber security posture. That is your multi-layered SATCOM security in the baseband. And the last is the integrated network and security management system, wherein the SATCOM and the networks over the terrestrial is able to talk to each other. Now, with that as the background, what does the Navy need? We need there are certain key developments which have the potential to leapfrog Navy SATCOM infrastructure, and we are looking at it very deeply, and that is how we will be able to augment the satellite segment. We need to ensure that the combination of the orbits that are available to us, that is being GEO, MEO, or LEO, we are able to exploit the complete gambit of orbits seamlessly. We need high throughput services at sea. Today, mostly the HTS services which are available ashore are ashore, and it's not available at sea. So that is what is required. Spot beams, multipolarity, and reusable frequencies are something which are coming in, and that is required to be tuned for the operations at sea. Once we have multiple layers of constellation, we have spot beams, multipolarity, and reusable frequency, we'll be able to dynamically use KU and Ka band. And once the platform are fitted with these antennas, we will be able to switch seamlessly between these two bands. And the rollout of 5G services over the land has given us the opportunity to see that these can get deployed over sea. So therefore, an aircraft flying from land to sea can seamlessly transit from terrestrial network to sea-based network. Coming to ground segment, our wish list are as flashed in the slide. Today we have LEO constellation being handled by multiple hubs. While I was browsing through the internet, I found that one of the hubs in the LEO constellation is able to handle 900 satellites every second, and that is some 10,000 handshakes per second. So that is the kind of capacity we need to have if we start using LEO constellation. ISA-based remote antenna systems are something we are looking at for our remote terminals, which will allow us to seamlessly move from one constellation to other. All our satellite networks are based on star network architecture, which greatly relies on hub. So today, if we want to establish a communication from ship to ship, why do we have to send a transmission from ship to hub and then again coming back to the ship? Why can't the ship talk to the other ship directly, or the ship talk to the aircraft directly? So that is where the mesh architecture comes in. It's a new concept. We need to put it in place. It will bring in the bent pipe concept onto the area of operations, and a single hop communication, greatly reducing the latencies. Automation in satellite and terrestrial network operations is a capability that we are looking at, wherein as the satellite comes more in number and it starts getting integrated with the terrestrial network, we will be in a difficult position to manage this complete network. It has to be automatized and completely AI-driven, software-driven. So that is one capability that we are looking at. And multi-layered baseband for SATCOM security, we have already spoken, which is a critical area for ensuring cybersecurity policy. Now, this is one concept that we have to handle it very, very importantly, because this is also alluded by Air Commodore Kane, that our cybersecurity posture in SATCOM services is very, very poor. And that happens because there is a proliferation of network connectivity happening. The COTS components are being put into the network. Therefore, the posture is getting weakened. So presently, our complete network security is based on perimeter security. We have to graduate from that and bring in the concept of zero trust architecture, wherein we ensure that any user who comes in with the initial policy of never trust. He has to be verified, start off with the least privilege, and thereafter move up the chain so that he is part of the network. If we don't do it, we will always have issues of cybersecurity threat in our network. And SATCOM is much more vulnerable because it's widely covered. The footprint is available anywhere and everywhere in the world. We have a limited infrastructure or expert available wherein we can carry out repair in space. The risk cascades and the third-party facilities are being used. So to conclude, I just want to highlight that we need to have indigenized solutions for critical technology. Today, Navy is faced with the challenge that how do I fit a terminal in a submarine? How do I fit a terminal in an aircraft? Wherein the form fit factor is much more smaller. So there we need to have indigenous solution. We need to have indigenous solution for encryption, both hardware and software. It's a big challenge that we are facing. And therefore, we need companies to come forward and help us with giving these solutions. I've already spoken about the dynamic switching part, where if the capability exists and if it is an indigenous solution, it will be a great use for our operational deployment. Quantum computing has already been spoken to. Satellite system and radiation hardening is something which we need to look at. We cannot leave our space assets vulnerable. It has to be hardened, both from the terms of cybersecurity and both from the terms of radiation. And the last point I want to cover is something which even US is struggling to implement, wherein we need to cultivate trusted commercial partners, wherein the complete supply chain infection is being addressed. We need to have trusted foundries, and this complete supply chain integration has to be ensured from the time the system is designed and to the time it is getting deployed on board the ship. With that, I have concluded. Thank you.
Thank you very much, sir. I think the kind of technology requirements that have been given by the services are very interesting. And rather than me asking questions, I will open the floor to the industry to get their clarifications. I think that will be more value addition for them. So anybody from the audience or the industry who would like to pose any questions to the panel, please. Sir, may I request if you could give out, say, the way in which the industry can engage, because there are a fair list of problems, and some have an overlap, some are very unique, and if you could give us some tips on how the industry can engage, may I request both all the three services to kind of address this question one by one.
The first part is that I think there is not adequate communication as far as space is concerned, because I personally have been dealing a lot in cybersecurity and IT, and now after having taken on this appointment in space domain, I realized that the awareness is lacking on either sides. So there is a requirement of having a proactive communication between both the segments, so that we are aware of what you have to offer, and you also are aware of the little nuances which the services actually require. That is one. The second aspect which I'll urge the industry is, I mean, had I been on your side right now, like I told during my talk, is 2022, the era where things are happening. And so people who are going to take the risk and adopt the fail forward strategy are the people who will be there, because you saw those 35,000 satellites. Out of that, we had only 198 registered here. I'm discounting the mere 60 odd of ISRO. So this is not a healthy sign. What we are looking for is that possibly the industry should take that leap of faith and go ahead. They don't, it's like what I see in the era here is that possibly the military will ride on the civilian networks. The demand is so huge. You don't have to wait for the defense. So you take that leap forward and let the technology and let your requirements drive the military, and they'll come to you possibly running that this is my requirement and please supply it. This is leaving aside the niche requirements, because the riding on civil requirements or dual use requirements is the best thing which can actually happen, rather than having completely captive solution in place. This is what comes to my mind. So
I think since the time I started interacting with Wing Commander Kushwa, and we have been speaking about the various initiatives that ISPA is taking on as to how to get industry into the space domain. And this is something which has been in the news of late. And with the considerable push for the government to be Atmanirbhar in the space, we actually need to see as to how we get more and more Indian industries into the space. And that is exactly what Wing Commander Kushwa was trying to say. Each of us, we have a problem statement at hand, and we have clearly articulated this problem statement as to what do we want. And that is what I was trying to highlight in my slides, that we clearly know exactly what do we want. So the first part would be probably we share this problem statement with the industry. There should be a central face of the industry coming to us and taking on this problem statement. And you give us the solutions of this problem statement as to what you can deliver as a solution to what we are trying to project. So that is part one. Second part is the process. In the process, we have the DISC challenge, we have the IDEX challenge, we have make one, make two. With that problem statement, probably you can go to the government, and the ministry, the additional secretary DP is having a meeting tomorrow, probably discussing all these issues. You need to go to the, and he is being tasked by the highest office in this country, that is PMO office, as to that we have to push space as an agenda for Atmanirbharta. So once you accept this problem statement, you come forward and say that this is what we can offer. Today, I'm very proud to say that our directorate is steering a DISC challenge on a gyro-stabilized SATCOM antenna. And we have 3 players from the Indian company. And I'm telling you, it is one of the most challenging tasks to design a gyro-stabilized, 4-axis gyro-stabilized antenna for a ship. It's one of the most challenging. But they're up to it. So we are actually pushing case to get space infrastructure in place through indigenous stores. Our SATCOM communication equipment in Indian Navy is 99% indigenous. Our SATCOM terminals are indigenous. Our encryptors are indigenous. Our networking devices are indigenous. So once you have this problem statement, you please come up and give us a solution. Thereafter, we will take it forward. Now, since we have opened this channel of communication, let's maintain it, and formally you form yourself as an organization and say that this is what we will do, and then we will take it forward. There are enough avenues for us to support you and get you through this process.
Firstly, I would like to tell the industry that in case they want to, if you have to engage with the armed forces, be ready for a long haul. That the industry has to be ready, and they have to be ready with the sustenance model as well, because whenever we do a lot of our procurements, we find everybody comes and tries to sell a dream to us, but are we in a position to realize that dream? So we may not come with a very big dream कि सर मैं आपके लिए ये satellite launch कर दूंगा. वो I know, that's a big dream, and if it happens, okay, none will be more happier than all of us, the nation. But that generally doesn't happen. So what say I, as if I'm talking on behalf of the Indian Air Force, what I would look at is Indianization of my ground stations. That's the first thing that I would expect from the industry, if they could help us do that. Because though we may have the defense PSUs and supplying all those terminals to us, but
if we talk of indigenization, the element of indigenization is very limited when it comes to the core technology. I understand we get limited because of the chip factor. Like when it comes to developing, designing, and manufacturing those ICs, there's a huge problem there. I remember way back when we were working on a project called the LRNG project, which has now metamorphosed into ISECS. So that was that low level radar networking group. And therefore, a single secure channel, Space Application Center, they had designed a box for that. And that single channel was, the size of the box was maybe 5U or something. 5U was the size of that for a single channel. The reason being, when we discussed with him, he said, Ki sir, that specific IC that we want, the FPGAs that we want, they are just not available in India. And if we ask those kind of ICs or FPGAs to be manufactured, you require a quantity. So I understand, yes, that is a problem which industry which is actually interested in indigenizing the equipment, that is one big problem that the industry is going to face. But nevertheless, you are the ones who can provide solutions to this. Modems. Modems is another area for the ground stations where we are facing a problem with respect to security. As I mentioned earlier during my presentation, that's one area where there's a huge security problem, and that if the industry could address, I think we'll be very happy with that. I think that's that's okay for now.
A small point. We were discussing as to how China has catapulted in a very short time in the space domain, and why we are not able to do it. And one of the most important two important issues that came up was the policies which dictated growth of space in China was top driven. Point number one. Second was the biggest issue that we face today for our industry to grow is capital. And if we are able to make a domain of funds of fund, they have a concept of funds of fund, wherein a strategic capability like space, which has a dual use, both civil and military, and space would become a new frontier for war. If you are able to have a concept of funds of fund, which is directly held by the highest authority of the country and is used for space augmentation, then we will be able to surpass this thing of that there is no fund available for. And a lot of funds can be made for this cause. Small fund.
Just 2 points. In fact, I'd agree with the point of the long haul part, sir. That's very, very pertinent, sir. Unfortunately, we've got our DAP in place, but come what may, the fact remains that whenever we have people coming from the industry and interacting with us, they need to get used to this long gestation period, which is very, very important. That is because, unfortunately, the kind of paperwork and the stuff that's involved is longish. That is something which you need to be prepared with. Probably the last closing point that I'd like to make in this entire set of discussion for the industry is, I had a discussion with the DPSU a long time back. My suggestion to the DPSU was this, and again I was discussing in something in terms of EW system. I said, you look at Samsung, or you look at Apple. They offer you at least 10 varieties of smartphones with different set of characteristics, with a different budget. Whosoever has whatever requirement goes there and picks it off the shelf. Please do not be GSQR driven. Please invest in your R&D. Please offer product to us. Like for me, who's wearing the OG, I'd say, okay, why only one in SAS? You give me 20 varieties of weapons with the same caliber, with different kind of night sight capabilities. Let me be the person who chooses what I want. But you offer it to me like a commercial vendor. Let me, as a consumer, have a large choice or a large base from where I can choose. So let's not be GSQR or that QR driven kind of an industry wherein we are waiting for proposals to come in. I know it's easier said than done. It's definitely going to involve a lot of budget, but then this is the way forward. You cannot expect, whether it's a central agency or whether it is the services working in silos, coming up and giving you your own tailor-made requirements that, okay, we feel this requirement is best suited to the Army, Navy, or the Air Force. Let's come up with a requirement which suits us all. After all, we're all talking in terms of jointness in times to come. How is it that the Navy can be working on a set of SDRs? The Army and the Air Force also need to be working on intercompatible SDRs, otherwise what's the use? That kind of intercompatibility is something that we need to work on. So the industry needs to follow the principle of, the kind of giants that I was talking about, and let's not be GSQR driven. Thank you.
May please request Rear Admiral K.M. Ramakrishnan to offer his closing comments.
Okay, I'll keep it short. I think you heard from the three services what the requirements are. It's not an easy go because space being a niche domain, it's difficult for the industry to put into R&D, invest, and then not find customers to sell their wares. The point brought out by Commodore Rajesh, I think, should be one of the way ahead. That is, the government funds gives a amount of capital which is available for R&D to the private as well as the PSUs. They undertake product development, and then it's available to the three services. With that, I would like to close, and I must thank all the speakers and, of course, the audience here for being patient listeners. And I see that there's no questions. So either you've understood everything, I guess that should be the way to go ahead. And all the very best. Thank you so much.
Photograph.